Today we're on page 2 of the Chapter 9 packet of Chemistry 1, and we're going to be learning about molecular compounds today and how to name them and write their formulas from their names. Molecular compounds are made up of all non-metals. So you'll recall with ionic that ionic always had a metal and a non-metal. Today, when we deal with molecular, it's all going to be non-metals. They're all going to be from this part of the periodic table to the right of this staircase right here. So if you have elements only from this part of the periodic table, that will be a molecular compound, and they're both going to share electrons. Here's a reason why you can understand that. If this column wants to gain electrons, to gain 1, this column wants to gain 2, this column wants to gain 3, it would make sense that if you put them together, two of them that want to gain, they're both not going to be able to gain. One of them is going to gain, and one of them would have to lose if that were the case, and they both won't do that. So instead of each one wanting to gain, they both share. And when they share, they each have more electrons to attain the same number of electrons as the noble gases. So in this case, you are not going to have pluses and minuses because you're not gaining and losing electrons, you're just sharing. So that means when you name these compounds, you have to use prefixes. Mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. These are the 10 prefixes that you need to know for molecular compounds. Let's take a quick example to understand even further why this makes sense that we have to use prefixes where we didn't have to use prefixes up here. So if I told you to write the formula for magnesium chloride, you could easily know that because you would look at the periodic table and know that magnesium wants to be +2 and chlorine wants to be a -1, and so you need 2 chlorines to go with magnesium, and therefore you would have MgCl2, and that makes sense. And you don't say magnesium dichloride, you just say magnesium chloride because you can figure out the formula by yourself with the charges for ionic. Same thing with the ternary, which has polyatomic ions, it's the same thing. However, if you're going to have a molecular and you wanted to write the formula for a molecular, you don't have charges to work with. So if you wanted to write CO and name that, you can't just say carbon oxide because, again, on this periodic table, you could see that C does not form bonds that are ionic, doesn't have a charge. Oxygen could make a -2, but since we're not dealing with charges with moleculars, we're not going to be able to write the formula just from naming it with each element by itself. So you have to use prefixes to tell the reader how many of each element there are. So this would be technically monocarbon monoxide. Technically, that's what this would be called. But if you start off a name with mono in the beginning, if it's in the beginning, you just drop it in the beginning. So this would just be called carbon monoxide. We don't drop the mono in the middle. We only drop a mono in the beginning. That's the only time we drop a mono. So this one has 1 sulfur and 2 oxygens. So again, technically you would write mono sulfur dioxide, but we just get rid of the mono in the beginning. This one has 2 nitrogens and 4 oxygens, so you would say dinitrogen tetroxide. So it's kind of like tetraoxide, and then you drop the A. So anytime you have an A before an O or an O before an O, like an oxide, you would just drop the A or the O. So instead of saying tetraoxide, you'd say tetroxide. Instead of saying monooxide, you'd say monoxide. So let's practice a little bit of these with a worksheet. Oops. Further along in this packet. This is the ending of worksheet 7. So with moleculars, what you need to understand is there are no pluses and no minuses, so you will actually just cross off these columns and say there are no pluses and no minuses. Now when we name these, we're going to name them for each part. So you'd say there's 1 silicon, so you'd say monosilicon, but we drop the mono, so just silicon. And the oxygen, there are 2, so you want to say di, and then oxide, you change the ending to ide. So silicon dioxide. Okay, this is called dinitrogen tetroxide. They dropped the A for tetra before oxide. So there are two N's. So we're going to write N2. And then tetra means 4. So they're going to be 4 oxygens. Tetra is a nice one because you could remember there's a video game that has this piece and this piece and a bunch of other pieces like this. And so the name of this game is called Tetris because every piece has 4 boxes. Okay, and then lastly, SF6, there's 1 sulfur, so you think monosulfur, but drop the mono, so it's just sulfur. And then 6 is hexa, so hexafluoride, don't forget the spelling of fluorine. Now all these are binary. We're only going to deal with binary, but there could be moleculars that are more than 2, but we'll just name them in 2s. And then these are all moleculars because they're all non-metals. So just remember when you do a molecular, you have to write the prefixes before every word except a mono in the beginning gets dropped. Any other thing in the beginning gets saved, and drop an A before or an O before an O.